dear lovely student, I hope you're all doing great. So today we have a new subject, and it is section 8 in chapter 4, theoretical probability, page 166. So theoretical probability used to estimate probability by what? By making certain assumption. By making certain assumptions, and about what? About an experiment. Then the rule of finding theoretical probability is number of favorable outcomes. Outcomes means results. Okay. Over what? Total number of possible outcomes. Or you can say that it is the sample space. All possible outcomes. So the number of favorable outcomes, the results, over total number of possible outcomes. If we explain with an example, it says, but before that, we have some great nodes. This is important, you have to note. If you do not know these nodes, these sample spaces, you cannot solve any question. So, first you have to know the sample space of a dice. You know what is dice, a cube number. Okay, it is 1, 2, 3 until 6. The sample space of a coin is head and tail. Okay, if you have two coins, one coin, okay, and also you have two coins. This is coin number 1 and coin number 2. So each of them, the first coin, let's say first coin and second coin. The first coin has two results. Okay, the sample space of the first coin is two results, head and tail. For the second one is the same. It has two results, head and tail. So if you have two coins, then what is the all possible outcomes? If you remember, we had a rule in the first, let's say, section in chapter 4, when you want to find, let's say, the possible outcomes, the sample space of 2 or 3 or more, let's say, events, it's going to be 2 times 2, it is 4. That's why if you have two coins, then we have 4 results. The results are head, 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 tail, or tail, 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 head. So whenever you talk about two coins, you have to know that we have 4 results, 4 outcomes. All possible outcomes is 4. Then if you have 3 coins, if you add up another coin here, again it has 2 results. 2 times 2 times 2, it's going to be 8. So from now on you have to know that if you have 3 coins, then we have 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. And the results are H, 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 T, H, T, H, T, H, H. Then we have T, 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 H, T, H, T, and also H, T, T. This is about 3 coins. Then, what if we have a coin and a dice? A coin and a dice. The coin, for the coin, we have head and tail. Then, for the dice, we have 1, 2, 3, 4, 5, and 6. Then how can you write all the possible outcomes for a coin and a dice? It's quite easy. Look, it's going to be edge 1, or you can say 1 and edge. It's no difference. You can start coin with the dice or dice with the coin. Edge 1, edge 2, edge 3, edge 4, edge 5, and edge 6. Or you can say 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, and 6 edge. For the tail is the same. T1, T2, T3, T4, T5, T6. So the coin has 2 results and the dice has 6 results. 2 times 6, it's going to be 12. As you see, we have 12 results for a coin and a dice. Then finally we have 2 cube number. Okay, 2 dices. Let's say you have a first dice, and also you have second dice. For the first one, the sample space is 6. For the second one, sample space is 6. 6 times 6 is equal 36. So whenever you have 2 coins, 2 dices or 2 cube numbers, we have 36 results, and you can see the result is 1 with 1, 1 with 2, with 3, with 4, with 5, with 6, then 2 with 1, 2 with 3, and so on. We have 36 results. Okay, then we are going to solve some examples, then you will understand more about the subject. First example, it says, an experiment consists of rolling a dice. Okay, it is 1 dice. We have only 1 dice. So it means we have 1, 2, 3, 4, 5, 6 results because there is only 1 dice. So the first question is, find the P of 5, the probability of 5. Okay. Then if you look at the list here, the all possible outcomes for a dice, how many number 5 can you see? It's only 1 time. Okay, 1 time is repeated. Then write 1 because we have number 5 here and repeat it only 1 time. So write down 1. Then what is the all possible outcomes? 1, 2, 3, 4, 5, 6. So 1 over 6. It means out of 6, let's say outcomes, 6 results, one of them is 5, then over 6, it is 6 is the all possible outcomes, the sample space of a dice. Then, what is the probability of even number? When you roll dice, let's say, what is the probability of getting an even number? So look at the results. We have the 1, 2, 3, 4, 5, 6. How many of them are even? So we have 2, 4, and 6. So there are 3 even numbers. Then P of even, it's going to be 3 over 6. Simplify it, it's going to be 1 over 2. So the probability of an even number is 3 over 6. Then it says P of 5 or 6. 5 or 6. 1, 2, 3, 4, 5, and 6. P of 5 or 6. What is the P of 5? The probability of 5, it is 1 over 6 because we have only 5, let's say 1 times that 5 repeated. Then plus, okay, what is the probability of 6? Again, it is 1 over 6. Out of 6 results, 6 repeated only 1 time. Then if you add them up, it's going to be 2 over 6. Simplified, divided by 2 is 1, divided by 2 is 3, so it is 1 over 3. That's why the probability of P or 5 or 6, it is 1 over 3. Then the probability of odd number. An odd number, how many odd numbers are there? It is 1, 3, and also 5. How many results? The outcome is 3. 1, 2, 3. So it's going to be 3 over 6, and it is 1 over 2. So for odd number, it is 1 over 2. Be careful. You have to be simplified. Sometimes when you say what is the probability of an odd number, when you look at the results, you cannot see, let's say, 3 over 6 in the result. Among the results, let's say we have A, B, C, and D. Okay, you cannot see 3 over 6. Okay, that's why you have to simplify it. When you find the result, for example, 2 over 6, 3 over 6, 4 over 6, if the, let's say, the fraction can be simplified, you have to simplify, then find choose the correct answer. Here, if you, let's say, check the answers in the Mishtimani question, you cannot find 3 over 6. That's why you have to simplify it, then it's going to be 1 over 2. Question E, it says, what is the probability of a number more than 2? Again, let's write the sample space 1, 2, 3, 4, 5, 6. Then what is the probability of more than 2? More than 2. This is 2. More than 2, 3, 4, 5, 6. How many results? 4 results. What is the all possible outcomes for a dice? It is 6. Simplify it. Divided by 2 is 2. Divided by 2 is 3. So the probability of a number more than 2, it is 2 over 3. Then, example 2. An experiment consists of tossing 2 coins. Tossing 2 coins. So, if you remember, I told you 2 coins has 4 results. The results are H, H, HT, TT, and also TH. So, this is all possible outcomes of 2 coins. Then, let's solve the question. It says, find the P of same faces. If you look at the results, how many same faces do we have? We have H and H. This is the first one. And also, what do we have? H and T are not same. T and T are the same. So you have T and T. That's it. This is the results. Then how many outcomes do we have? We have 2 outcomes out of 1, 2, 3, 4. Okay, so for the same faces, it's going to be 2 over 4. After you simplify it, it's going to be 1 over 2. So the probability of same face when you toss 2 coins, it's going to be H and H, T and T, 2 over 4. Why did we write 4? Because for 2 coins, we have 4 outcomes. All possible outcomes is 4. Then, if you change the question, what is the probability of different faces? The faces are different. If you look at here again, we have HT and TH. They are different. So it's going to be 2 over 4. Simplified, it's going to be 1 over 2. Then, the last question. This is B. This one is C. The probability of at least 1 head. At least 1 head. Again, I'm going to write the least. HH. Okay. HH. HT. TT. TH. It says at least. Among this list, among the outcomes, okay, at least you see 1 head, at least. So we have here, and also we have at least 1 head, at least 1 head. So 1, 2, 3 results. So it's going to be 3 over 4, and it is the simplest form. So the probability of at least 1 head when you toss 2 coins, it is 3 over 4. Okay. An experiment consists of rolling 2 dice. Again, I'm going to remind you, consists of rolling 2 dice. It means this is the first dice times the second one. It's going to be 36 results. So we have 36 results. Then it says probability of P of total shown 1. It means, let me explain it. This is the first dice. 1, 2, 3, 4, 5, 6. Again, you have 1, 2, 3, 4, 5, 6. This is the first dice, and this is the second one. It says between these 2 sets of number, okay, these 2 outcomes, can you add 2 numbers and gives you 1? For example, let's say 1 adds with another one, another number gives you 1. So it's impossible because you cannot add two numbers here and gives you 1. That's why the result is 0 over 36 because we have two dices. That's why we wrote 36. So the result is 0. It means it is impossible. It is impossible. Okay. Then the probability of at least 1/6. Okay, among the order pair when you write them. Okay, at least showed 1/6. You can see that it is 1 and 6, 2 and 6, 3 and 6, 4 and 6, 5 and 6, then 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, and also 6 and 6. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 results that consist of at least 1/6. Then it's going to be 11 over 36. 11 over 36, and it is the simplest 4. Then question C, P total shown 7. It means you have to add two numbers, gives you 7. So the results are 6 and 1, because 6 plus 1 it's going to be 7. Then 1 and 6, always when you write let's say an order pair, then after that write the opposite. 6 and 1, 1 and 6. 4 and 3, then the opposite, 3 and 4. Then 5 and 2, 2 and 5. So right now if we count them, 1, 2, 3, 4, 5, 6. So we have 6 results that gives you 7 when you add. So we have 7 out of 36 results because we have two dices. So not 7, we have 6. We have 6 results that gives 7. Then it's going to be 6 over 36. Simplify, divided by 6 is going to be 1. Divided by 6 is going to be 6. So the result is 1 over 6. So I'm going to repeat it, please. Try to simplify it, because in the multiple choices you cannot see 6 over 36. After you've let's say simplified, the result is 1 over 6. Then we have a total shown 12. Add two numbers among the sets and gives you 12. There's only one result, and it is 6 plus 6 is equal to 12. So we have only one result. That's why only one result. That's why the answer is 1 over 36. The last question says P total greater than 8. Greater than 8. So let's write P total greater than 8. It means when you add these two numbers, gives you a number that's greater than 8. For example, if you write 4 and 3. 4 plus 3 is going to be 7. Is 7 greater than 8? Of course, it's not. So that's why it's not included. Then what do we have to write? We have to write all the results that gives you a number that's greater than 8. So here I'm going to write all the numbers that gives us greater than 8. So we have 4 and 5. Write the opposite, 5 and 4. Then we have 6 and 3, then 3 and 6. Why? Because 6 plus 3 is 9. Okay, 3 plus 6 is 9. It's greater than 8. Then 5 and 5, because 5 plus 5 is 10, greater than 8. Then 6 and 4, 4 and 6. 4 plus 6 is 10, so 10 greater than 8. Then we have Then we have sometimes the students are going to make a big mistake. For example, some of you, they are going to write 4 and 7. Okay, maybe some of you write, let's say 5 and 8. It says 4 plus 7 is greater than, it's equal 11, and 11 greater than 8. Or let's say 5 plus 8 is going to be 13, 13 is greater than 8. It's not correct. You have to be careful. We are talking about a dice. You should know that dice has 6 results, 1 until 6. You cannot use 7, you cannot use 8, 9, or any other number. Only 1 until 6. 1, 2, 3, 4, 5, and 6. You can use only these numbers, not the rest of the numbers like 8, 7, because we don't have 7 here. Please do not make that mistake. So, then we have 4 and 6, then 6 and 6. So the results are, say you have 10 results. It is 1, 2, 3, 4, 5, 6, 7, 8. You have 2 more results. We have 6 and 5, and also 5 and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 results. If you add them, they are going to be greater than 8. So it's going to be 10 over 36. Simplify it, it's going to be 5 over. Divided by 2, it's going to be 5. Divided by 2, it's going to be 18. So the result is 5 over 18. Example 3, it says, this is one of the important examples. It's important. It says, a bag contains 5 blue balls and 8 green balls. How many yellow, be careful, it says yellow, not the other colors. How many yellow balls should be added so that the probability of a green ball is 2 over 5. So we have to find the number of the yellow balls that you have to add it. Then the probability of green is going to be 2 over 5. It's quite easy. So right now, always focus on the first of the, let's say, probability that is given. It is 2 over 5. Write down 2 over 5. So then equal. 2 over 5 is the probability of what? Of green. Then how many green are there? 8. So write down 8. Again, we have the given probability is 2 over 5. Write down 2 over 5. Because it is the probability of green, that's why we wrote 8 here. Maybe ask that question, why didn't we write 5? Why did we write 8? Because it says the probability of green. That's why we wrote 8. If it says the probability of blue, then we would write 5 here. As you know, for the denominator, we have to write the total. Then how many balls are there? 5 plus 8, it's going to be 13. So write down 13. Write down 13. Then, for the question, it says how many yellow balls should be added. So here in the total, how many yellow balls should be added? And instead of yellow, you are going to write a variable. It is y or x, no difference. So this is the equation. Then you have to find the number of yellow, that is y. How to find it? We are going to use cross product. Here, 8 times 5, it's going to be 14. Okay, and then 2 times 13 plus y. So we have that equation. Then 2 times 13 is 26 plus 2 times y, it is 2y is equal 14. Then move 26 to the other side. 2y is equal 4t minus 26. So 2y is equal 4t minus 26 is going to be 14. Then divide both sides by 2, divided by 2, divided by 2. Then y, okay, is equal 7. So we have to add 7 yellow balls to the total of the number here. Then the probability of green is going to be 2 over 5. The probability is going to be 2 over 5. Then one last thing that we have, it is mutually exclusive, or you can say disjoint events. It says are two events that they cannot happen at the same time. For example, let's say when you have a coin, so you have a coin, okay, you toss the coin, you throw it. Then we have head and tail. Can you say when you throw a coin, when you toss a coin, you can get head and tail at the same time? So it's not possible. So we call them disjoint events, okay? Or let's say when you have a dice, you roll the dice, you get 5 and 6 together, and 5 and 6 together. So it's impossible. You cannot get 5 and 6 together, or you can say, or let's say head and tail together. So disjoint events are, let's say, two events that they cannot happen together at the same time. Okay, so P of A and B is equal 0. It's impossible because they cannot happen at the same time. But P of A or B, we are going to add it as we solve it. P of, let's say, 5 or 6. P of 5 is 1 over 6 plus, this is or, not and. P of 6, it's 1 over 6 is equal 2 over 6, and it is 1 over 3. So you have to be very careful that there is a big difference between and also or. When you say and, it means both of them happen at the same time, okay? And it's impossible. But when you say or, let's say 5 or maybe 6, okay? It is possible. But for and, it is impossible. Then finally we have some nishtimani question. The first question is, two coins were tossed. What is the P of HH? As you know, we have HH, HT, okay, TT, and also you have TH. Then how many results do we have that shows HH? There's only one result. So it's going to be 1 over 4. Out of 4 results, only one of them shows HH. Question 2, it says 3 coins were tossed. What is the probability? P of only 2 heads. P of only 2 heads. 3 coins. Okay. If we have 3 coins, then the results are, let's say head, H, H, H. Then we have H, H, T. Okay. H, T, H. And then we have T, H, H. For the others, it's going to be T, T, T. Then we have T, T, H, and also T, H, T, H, T, T. So we have 1, 2, 3, 4, 5, 6, 7, 8 results. Then it says P only, not at least. Only 2 heads. How many results do you have that consists of only 2 heads? So here we have 3 heads. It's not included. 2 heads, 2 heads, and also 2 heads. Then how many results do we have that consists of 2 heads only? So 1, 2, 3. So we have 3 results that consist of 1, 2, 3. So it is 3 over 1, 2, 3, 4. So we have another question, question 3. It says a spinner was spinning 220 times. The outcome was red 58 times. Estimate the probability the spinner landing on red. So we have P of red, then it says the outcomes of red is 58. Then what was the total number of spinning that we did with the spinner? It is 220. So we divided, it's going to be close to 0.264. 0.264. Then question 4, it says in a fair cube number, P of a prime number, we have one cube number, 3, 4, 5, and 6. Then how many prime numbers are there? We have 1, okay, 2, and 3. There are 3 prime numbers. Then the result is 3 over 6, and it's going to be 1 over 2. Be careful, 1 is not a prime number. Okay, 2, 3, and 5 are prime numbers. Then the result is 1 over 2. Question 5. In 2 fair cube numbers, P total is equal to 10. You have 2 fair cubes. You should know that because it's 2 fair cube, 2 dice. We have 6 times 6, 36. Then, how many results do you have? If you add them up, it gives you 10. Then, I'm going to write the results. 5 plus 5. Okay. Then, 6 plus 4, and 4 plus 6. Do you have any other results here? So we don't have it. We don't have it because we have 5 plus 5 is equal 10. And also we have 6 plus 4 is equal 10. And also we have 4 plus 6. We cannot write 7 plus 3. Maybe you think about 7 plus 3. 7 plus 3. Or you can say, or maybe you say 3 plus 7. But it's not possible because you should know that we have a dice that is numbered from 1 until 6. So the result is 1, 2, 3. 3 over 36. It's going to be divided by 3 is 1, divided by 3, then it's going to be 12. So the answer is 1 over 12. D is the correct answer. Question 6. Again, it says in 2 fair cube numbers, P total less than or equal to 12. Let's explain it. 1, 2, 3, 4, 5, and 6. This is the first one. 1, 2, 3, 4, 5, and 6. This is the second one, the second dice. Then it says all the results, okay, when you add them up, it gives you 12 or less than 12. Then look at the all results. 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6. They are less than 12. Then you test 2 with 1, 2 with 2, 2 with 3, and so on. All the results are less than or equal to 12. That's why it's going to be 36 over 36, and it's equal to 1. So the P of total less than or equal to 12, it is 1. Again, it says 3 coins were tossed. What is the P of H? It's quite clear that it is 1 over 8 because we have only one result that consists of H. The last question, it's question 8. We have a bag contains 3 red marbles and 6 blue. It's not 66. 6 blue marbles in it. What is the probability of red. So P of red is equal. P of red is equal. How many red are there? There are 3 red. What is the total? 3 plus 6 is equal 9. So 3 over 9. Simplify it. Divided by 3, it's going to be 1 over 3. So the result is 1 over 3. So, dear lovely student, I hope you get benefit from me. So this is the final, or let's say last question in this section. I hope you get benefit from me. Thank you so much. Have a great day.